class 11th, I am telling you about the work energy theorem. This is a very important theorem and it has the wide applications. So let us find that what is the work energy theorem. As the name suggests that here we are having two things, one the work and second the energy. It means that work and energy are related with each other. So now let's let a body of mass m is moving with velocity v1. A force F is applied up to a distance x, so that the final velocity of body is v2. So now what we are having, this is a body. This is moving with velocity v1. Its mass is m2. And now let's if force F is applied on it in this direction. This is now force. So the body moves to a distance x such that its velocity becomes v2. This distance is x. So much is x. It means that the force is applied in the direction of the velocity, so the velocity will increase. And the acceleration A equal to F upon m. Now we apply the third equation of motion. Applying the third equation of motion. This is equal to your v square equal to u square plus 2as. Now here what we have? This u equal to v1 and v equal to v2, a equal to f upon m, and this s equal to x, this distance x. So now we can have, if we put all these values here, then you will find that this is now your v2 square, this is now your v1 square plus 2f upon m into x. So this is your v2 square minus v1 square equal to 2fx upon m, or this is half m v2 square minus v1 square equal to fx. So now by definition, this Fx is the work done. By definition, work is equal to Fx. Therefore, W is equal to 1 by 2 m V2 square minus 1 by 2 m V1 square. So this is what? The K2 minus K1, and this is equal to delta K. This is equal to W. Where K1 equal to half m V1 square and K2 equal to half m V2 square. So you will find that this is the change in kinetic energy. Delta K is the change in kinetic energy. This is the initial kinetic energy, this is final kinetic energy. So this K2 minus K1 equal to the change in kinetic energy. So in this article, I have shown that the force is being applied in the direction of the velocity. Then the velocity is increasing, but force may be applied opposite to this one also. So the kinetic energy will decrease, and that always we are having a term, the change in kinetic energy. So change in kinetic energy is equal to work done. It is called work energy theorem. It states that change in kinetic energy is always equal to the work done by force. Work done by force. If suppose this kinetic energy decreases, then this W equal to minus delta K. And if the kinetic energy increasing, then W equal to plus delta K. So in that way, if there is suppose no change in the kinetic energy, then work done is equal to 0. If delta K equal to 0, then W equal to 0. It means that the body is moving with the uniform velocity. So when a body moves with the uniform velocity, then no work is done at all. So work energy theorem says that the work done by the force is equal to 0, or no work is being done by the force. When a body moves with uniform velocity, the work done is 0. So now I will give you that the work done, that work done by the viscous force, or like the friction force, viscous force, all these, the work done is always negative. special cases. Work done by friction and viscous force is always negative because they oppose the motion of body. It means that delta K is equal to negative. So work done by what? The friction force or work done by viscous force, this is equal to negative as delta K equal to negative. So they are always opposing the motion of the body, and so the change in kinetic energy is always negative. So the work done will be negative. So that again that we can have this relation with this. That's the delta F equal to, this is now equal to half m v2 square minus v1 square. So this delta F, since v2 is less than v1, therefore this delta F equal to negative. Similarly, suppose the body is moving on the inclined plane, then the work done by the friction, that will come out to be 0. Motion on the inclined plane So now what we are having, that this is now suppose the inclined plane, this is now suppose angle in theta, and the body is moving from here, its velocity is equal to v1, and here this has the velocity v2. Let this now height h from here. When the body is moving on the inclined plane, then we are having the work done by this is the potential energy, gravitational potential energy, plus work done by friction. This is equal to half m v2 square minus v1 square. So this is what? Where WGP equal to the gravitational potential energy. Gravitational potential energy. This is equal to mgh, and this wf work done by friction So you can have that when the body is moving from lower to the upper part, this to the height h, then definitely there will be the potential energy, that is now mgh, and this is your wf, that the work done by the friction. So this is equal to mgh, then we can have mgh plus wf equal to half m v2 square minus v1 square, or this wf equal to 1 by 2 m v2 square minus v1 square minus mgh. This will give you the work done. Similarly, if suppose some body is falling in the air, then the viscous force will act on it. So the work done by the viscous force and that the change in the potential energy, that is equal to the change in the kinetic energy. Body falling from falling freely in viscous medium like air. This is now suppose a body here, this is falling, and let here, this is now ground, and here suppose this is now velocity or v1, and at this point the body is reaching, this is now suppose the velocity is v2, and let this side moved by the body, this so much, this is equal to x. Then what we have, that if we apply the Bernoulli theorem, then work done by air plus work done, this is gravitational potential energy, WGP, this is equal to half m v2 square minus v1 square. Like that we will have. So this WA plus this is now your mg. Now this height, this is now x. So this is now your mgx plus this is equal to 1 by 2 m v2 square minus v1 square. So we have this WA equal to half m v2 square minus v1 square minus mgx. This is so much. This is what WA is the work done by the air friction. WA is equal to work done by air friction. If you calculate it, then it will come out to be negative. So the work done by all these dissipative forces is always a negative quantity. So in this way you can have you can find the work done by this viscous force or by the force of friction or some other forces if they are acting on the body. So this is what the importance of this work energy theorem. So whenever there is a change in kinetic energy, the work will be done at the cost of the applied force. So thank you very much.